Welcome to Driving Supply Chain Innovation with AWS Cloud and AI Solutions. My name is Deborah Simeone. I'm our global head for restaurants at AWS. So I have an interesting role where I spend my days talking to restaurant operators of all sizes all around the world. And the one thing that fascinates me most about hospitality is doing it at scale. So when you think about it, if you walk into a McDonald's anywhere in the world, no matter where you're from, you're going to get the same experience. And there's something amazing about that. That type of experience doesn't just happen. It's engineered with the invisible backbone of the restaurant industry, which is our restaurant supply chain. So today I'm joined by two leading supply chain experts in the restaurant space. First, we have Samir Patel. He is the Senior Director of Supply Chain Engineering at Sysco, which is the world's largest food service distributor. And then we have Stephanie Koenig, Senior Director at McDonald's. Now, McDonald's needs no introduction, but when you think about the level of hospitality at scale I was describing, you're going to be surprised at some of the complexity in supply chain that McDonald's deals with on a daily basis. And Sysco and McDonald's, they're on the opposite end of the supply chain spectrum at AWS. But what we find is that they're using AWS in unique ways to serve their customers and transform the ways that they're meeting the needs of restaurant and diners. Whether you're in supply chain today, or you're in operations, or you're in tech or product, I promise you're going to learn something today from Stephanie and Samir about how to build something, how to scale something, how to achieve operational efficiency with excellence when you've got high stakes and massive scale. And I want to show you a little bit about what the scale of the restaurant industry is that we're talking about. McDonald's operates in over 120 countries, and what that means for McDonald's is that they're dealing with regional differences in the suppliers, in the regulatory environment, and even the logistics networks that they operate in. And then you have Sysco, which is serving 750,000 it's three-quarters of a million restaurant customers every single day, making sure they have what they need when they need it. And what's even more complex about Sysco and McDonald's is that they're dealing with fresh food. And when you're dealing with fresh food, time and temperature are everything. So both these organizations have a lot in common. And the biggest thing that you'll learn today they have in common is that they've used AI to unlock the potential of their supply chains. And that's the transformation that you're going to hear about today. You're going to learn about real solutions that are in production right now. They're making intelligent decisions that are impacting millions of meals, even just today. And so I'm going to go ahead and hand it over to Samir now. He's going to walk you through some of Sysco's journey and how they got to a place where they're transforming their operations on behalf of their customers using AWS. Welcome to Samir.
Thank you, Deborah, for the warm introduction. So today, I want to share an amazing journey, transformation journey that Sysco has gone through. We have a lot accomplished part of the transformation. Also, I want to talk about our strategy, how we went about it. Also, AWS, which is a foundational thing that really help us achieving our goals, and also talk about some of the AI vision and use cases that we have, and a lot of lessons we learned. Our journey was very difficult. It wasn't easy, but I'll use simple term to explain you how we went through about it. Show me your hand if you heard about Sysco or have seen our iconic truck. All right, almost many people. Show your hand again if you actively going through some sort of modernization or transformation. Okay, so you are in the right session. So I will first start with Sysco. Sysco, by large, it's the #1 food distribution in the world. I want to start also with one fun fact. So Sysco is a 56 years old company. And also, by S&P ranking, we are also 56. Our numbers are shown on the screen, right? We have 730,000 customers We have 500,000 SKUs, $81 billion company. So it's a great example of legacy company that's showing the growth and also innovate. We are always looking ways how do we innovate and deliver better solution to our customers at the right price and the right products that we have. We have presence in 90 different countries, and we have 340 plus distribution centers. So that kind of tells how complex we are. But for today's conversation, I want to focus in supply chain. So let me kind of double click into that. Every solution we have, we try to put S in front of it. So our warehouse management system, we call it SWIMS. So there are two key objectives, part of our warehouse management system. But before that, I want to say that Sysco has grown by merger and acquisition, right? So we have been growing for last 56 years. There is a growth that way. So we want to always optimize and innovate when it comes to our warehouse operation. So our warehouse workforce, we want to give them tools and processes where they can focus on the operational efficiency, as well as we want to have the better workflow in our warehouse. So that at least translate into delivering products and orders to our customer faster. And at the same time, we are optimize our warehouse operations. So now if I can go further into our warehouse management system, we have about 110 locations where we have deployed this purpose-built custom solution. We, as I said, it's a SWIMS. It's a 25, 30 years of innovation enhancement that we have done. And as you can see the scale, it's in the multiple countries. We have 15,000 warehouse associates are using it, and we are processing over 2 billion pieces per year. Also, we have different business units, geographical locations. We also have our regional distribution center, central warehouses. So there is a different complexity and different kind of flavors that it brings. Now, I want to talk about some of the challenges. So as we have built this over the last 25 years, the complexity grew, right? So we have over 1.5 million lines of code. We have a lot of integration with systems in the warehouse, as well as we have different ERP system. And some of the technology that we had is the Oracle Suite product. So we have had UI in Oracle Forms. Our database is Oracle. A lot of logic in the PL SQL. We had Pro-C, like, so you name it, right? There's a lot of legacy technology that was preventing us to innovate. And even if you have to upgrade, it was taking a lot of time. Deployment is another thing, because even though we have 110 warehouse location, it's one code base, but we were deploying into all location one by one. So it's a single tenant system that deployment happens. And every time we have to deploy a new release, it's time consuming, and we can only deploy during the downtime or the weekend maintenance window. And it takes 2 to 4 hours. So you can imagine, like, if we have to roll out to all 110 sites, it takes so many weeks. So there are a lot of challenges that we faced. And then it's hard to innovate on top of that, because now everybody's talking about AI, agentic AI. But if you want to do something, that's also another challenge. So what we did is we kind of looked at, like, we had a vision, like how do we transform, right? We have a strategy and also the execution plan. So let me start with why we want to modernize. So one of the main thing from business side is, like, we want to have more intuitive experience to our warehouse associate that can help translating into the better productivity. And as we have new associates, we gone through the COVID time, right, where we had labor shortage and so many other issues. So there are challenges with the warehouse. So there are new associates come, and how do we train them faster, right? How do we make it more intuitive so they can finish their job very quickly? At the same time, we want to technically, like, use the hardware and software which is cloud native, so that we can pick up the speed, deployment-wise, upgrade-wise, and also develop the new capability and deliver to our customer. Another thing, also part of our warehouse is we have associates that they are working in different climate zones. So we have a dryer, freezer, and cooler. So imagine like, they have to pick up orders from all different aisles and then and kind of pack as an order. So there's a lot of complexity in our warehouse. Also the users in our warehouse, they are using different devices, right? So there is a browser-based application that 30% of the associates using it, but the remaining operation, 70% of that, is going through forklifts. They have RF guns, they have wearable devices, so they use different sort of mobile devices to finish the warehouse workflow. And within four wall of a warehouse, right? Typically, you have different shipments coming. We put it away. We also have cut-off time, and then we pick up the orders and we ship it to our truck and deliver it, right? So there's a lot of things happening, and the returns also coming. So everything has to happen. So that's something we want to modernize. So how we want to do it and how we did it. So we kind of focus on the user experience to begin with, where yes, we want to use the cloud native solution, modern stack, all that is great. But starting with user experience, where the browser-based behavior is more using React, cross-browser, responsive UI. That's number one. The mobile apps, which were Windows CE, now we are moving to Android, and the new application that we have built, which are Android-based. And as I mentioned about single tenant, right? So instead of just focusing on single tenant, we want to have regional-based deployment, where instead of just deploying one at a time, we can have more releases going to the region. So that way it's a multi-tenant, and these are some of the objective, and as well as we want to optimize the cost, because some of the thing I mentioned, like we had Oracle stack, so there's a lot of cost involved with that, as well as the upgrade cost. And also, because of the old legacy technology, it was very, very hard to find the talent. So there is a cost in different ways. It's a human cost, hardware cost, software cost, right? So we wanted to kind of go beyond that. And why AWS, right? But before I go there, I want to talk about important aspect or approach we took. So, those who are kind of going through modernization or done it, you may heard about sidecar approach and a strangler pattern, right? Sidecar approach is where you have the old system running, and then you build a new system on the side, and then you have both running in parallel, and then slowly you build capability here and then retire the old one. But in our case, that was not the viable solution, because there's a lot of things need to be implemented in the sidecar, and you cannot get the business value faster, and it's a cost issue also. So what we did is we built a strangler pattern, where strangler pattern is where you keep the one code base, but also build the modern stack slowly, and then shrink your old stack and build a new one, and both can coexist. So a lot of those things, plus cost, we want to innovate faster, deliver faster. So blue-green deployment, canary deployment, right? There are a lot of aspects how we can go about it. Also the database I mentioned, right? So Oracle Enterprise Edition is what we were using in the private data center. So looking at different clouds and different options and different strategy, AWS was a natural choice for us. We are able to use RDS and standard edition, and I'll touch upon some of the benefits in the following slide. But those are some of the things, as well as the cost, because there is a dual run cost, right? You have the old stack running, you have the modernization stack running. How do we optimize the cost? And innovate faster, because as we kind of start deploying the modern stack, there's a lot of cool technology or AI-driven technology that we want to benefit out of it. So considering a lot of that, we decided that we want to have AWS as our foundation. Going further, so this is very high level, like our cloud architecture. So what we built with the modern stack and moving from our on-prem to AWS it's not just a lift and shift, but we wanted to build the architecture which is very resilient, right? In a single region, we are highly available, and in a multi-region, we are active passive. So highly available where we have strangled pattern, as I said, right? So we have old stack and the new stack both running together. The old stack, from the compute wise, we are using EC2 instances in the multiple availability zone, right? So that gives us the resiliency. Also in the DR space, so we have Oracle RDS database, right? And we are taking snapshot and kind of putting into the second region. So whenever the region has some issues, we can always start that second region and kind of get that going. All the new stack we have, we are using serverless. So Fargate as an example, we are using Lambda function, right? So there are a lot of key services that we are using out of AWS that gives us this architecture. And kind of also we build the proactive monitoring. So we have enterprise monitoring tool Datadog, so very native integration with that as well. And even the recent AWS outage, right? This architecture was proven that it worked and we did not have any issues. So likewise, there's a lot of advantage that we got out of this architecture. And it's a well architecture framework also, right? So we kind of embrace a lot of good practices part of that. But if I fast forward now, right? And I want to talk about the benefits. So in a record time, right? I talked about the complexity, number of challenges that we had. We were able to migrate all 110 sites with zero rollback in a year. This is like a historical moment for us. Also, like on the right hand and left side, you can see the RTO, RPO, service level objective, recovery point objective, and recovery time objective, right? So in the same region, we have very impressive numbers when it comes to HA. And also when it comes to DR, compared to our on-prem infrastructure, we were able to have 50 times more better numbers. So that's because of AWS. Also the rollout, right? I mentioned about 2 to 4 hours deployment speed. Now we are able to deploy all sites within a day, which is 8 hours, right? Part of the migration, it was not just the lift and shift, right? We were able to make a lot of security improvements. So, security in transit, security at the rest. So database level encryption, HTTPS wherever possible. Also the password rotation, right? So using Amazon Certificate Manager, Secrets Manager, right? Those are some of the AWS services really help us to achieve a lot of security and cyber improvements. Even the AMIs we have, we call golden AMIs in Cisco, which are like that created by Cisco, putting all the right hooks. So we use that AMI as part of deployments also. Another thing also, so proactive monitoring. So we have hooks into ServiceNow, we have hooks into Datadog, and we kind of build a lot of features part of that, where how the modern stack is used, how we can troubleshoot better, right? So there is a lot of monitoring that we build. I want to also touch upon the saving, because as you modernize and start deploying it, you have to worry about cost. So AWS has a very great program called Migration Acceleration Program, which is a MAP credit. We tapped into that. Our AWS team really helped us achieving that. And that was really great to have a dual run cost. But no, we didn't only stop there, right? We have RIs, we are also parking the infrastructure, and all the infrastructure that we have is very much like we can script it, create it, use it, and remove it in non-production environment, right? And production also, the RIs, savings plans, there are a lot of things on top of that we leverage, which gives us the cost benefit. And we are running like half of the cost compared to our on-prem. Even the support cost I was mentioning about it. So we moved from Oracle Enterprise Edition to Standard Edition using RDS, AWS RDS. So that helps us, saving a lot. And then, a lot of capabilities that we got out of that, more capability at low cost, right? So those are some of the benefits that we realized out of this. So what's next, right? So part of modernization, we have modern stack. We are actively deploying it. We have both the legacy or old stack and the modern stack running side by side in production, and we are actively deploying, to different sites. So we have now a vision, right, which is more about getting into AI. So we want to have connected experience to our warehouse. And it's not just the agentic, but there are automation use cases. We have vision use cases, robotic use cases. So kind of combining all of that and building the smart supply chain. So this is a kind of a blueprint, but I want to take a little bit time and talk about 3 specific use cases that either they are in the early stage, some in the further stage. So let me touch upon that quickly. The first one, this is a very technical use case, right? We call a route ripple. So imagine like 110 warehouses. There are issues happen, right? How do we go about reactive resolution to proactive solution? So there is a data coming from ServiceNow. There is a data coming from the incident. We have Datadog. We have runbooks. So this is a solution that we implemented using GitHub pilot just to begin with, and it is basically looking all the data. It has an LLM running, and then basically it can find if there is a pattern, if this issue was happened before, it can give you a resolution, or it at least navigate like how can we go about solving the problem, right? Something that we deployed using the Kubernetes, but we were able to save a lot of time, right? So we can run like 30 minutes, our MTTD is like reduced by 30 minutes. Even the recovery time reduced in half, right? It's more than, it was 6 hours, now it reduced to 3 hours. And importantly, the productivity of our associate who are troubleshooting, that got drastically reduced, right? So now they can use that 10 hours to do bigger and better things. And this solution is not just for our warehouse, but we can take this and apply to everywhere, right? That's kind of the power of it. I have another interesting AI use case, which is more about the transportation space. And by the way, this is a hackathon winner. I have one of my team members sitting here. He's the one in pioneer of that. But before I talk about the router IQ, who is router and why there is a lot of manual things happening. So routers are the human being working in the warehouse, right? So Cisco has this concept called cut-off time, where every day, like around 4 or 5 o'clock, depending upon the site, we stop taking the orders. And depending upon what are the orders we need to deliver for the next delivery date, there is a person or set of people sitting in a warehouse. They look at all the orders for the day that has to be delivered, and then look at the customer location and figure out what should be delivered, what is the optimal route, how do we pack this order together so it's efficient and deliver on time, because every customer also has a time where order should be delivered. So combining all of that, a person has to spend time and figuring out like, what is the optimal route. So the AI solution that this was a POC, but we are gonna actually going about implementing it, and I'm gonna tap into my cheat sheet here. So we still want human in the loop, right? So we want router to be the final decider. Like even though AI can say, hey, this is how the optimization work and this is how it should be delivered, we want the final saying to be done by router. So for optimization engine, we're going to be using Cloud LLM and then LangChain as a framework. Plus, we have the hybrid VRP, and that's something, for the shortest path engine. And the third thing is like, how do we go about deploying, right? So we either use ECS or EKS cluster, and then we are, for the data streaming and getting data from different systems, we are using Kafka pipelines, right? So those are some of the technology that we're going to tap into. But there are benefits, right? That's improving efficiency of our warehouse workers, as well as delivering products to our customer faster. So those are some of the key advantages that we can see from this. And then I have one more use case. This is more about your traditional AI ML use case, where we have AI-driven inventory optimization. So in the about Sysco, I talked about we have about 500 SKUs, right? So many different items that customer can order. And also when customer is ordering through our e-commerce channel, we call it shop, they can look at the items, but sometime what might happen is it may show item is there, but when we try to fulfill after the cutoff time, item may not be there. So there may be a stock out, right? So that can lead into unhappy customer, or we have to substitute item which customer may not like. So with this AI ML use case, and that's something we want to build using SageMaker, can really help us transform like how we can have the AI-driven inventory, and kind of some of the key benefits that listed here is mostly talking about initial MVP, but we want to go further, right, and improve how we can do this. So those are some of the use cases I wanted to share. And then I want to close it off telling some of the lessons learned, right? So part of the transformation journey, very important thing is there will be challenges, right? And we had full of challenges, but what we did is we navigated through that. Have your team and empower them, right? I think you need to have a strong engineering team and great relationship with your business partner and product team. And there'll be different things happening every single time, right? You have to swim against the tide, but if you are intentional about it, you can definitely get there. So do that. Automation is a key, right? So we try to automate everything. So getting migration done, so getting a database backup, snapshot, infrastructure as a code, deployment pipeline, even the DR testing, even the going from one availability zone to another, right? There are a lot of things when it comes to running your workload on a cloud. Automation is a key, right? Even one quick example I can share is we recently upgraded the RHEL release, and it was like something we did it middle of the day, zero downtime, right? So that's the power of automation. So definitely do that. Also, I think the cost-wise, I touched upon some of the aspect in the benefits. So that's one thing you need to worry about is like manage your cost, because you don't want modernization to take a lot of money and time, and then that get deprioritized, right? You want to optimize the cost as you go. And then the innovation, right? So AWS is a really strategic partner. Definitely tap into that, work with them closely, and also the business partner and the core teams that around your department, work with them, right? And also think about innovation, because it's not about just going from where you are to cloud and just modernize the stack, but what's next, right? Always think about it and be strategic about it. So that's it for today. Oh, and I know there is no Q&A here, but I'll be spending like an hour in the expo hall, 2 to 3 p.m. So if you have any question, please stop by, or even if you have your story to share with me, I'll be there. And with that, I will hand it over to Stephanie, and she'll talk about her journey at McDonald.
Hello. As Deborah mentioned, my name is Stephanie Koenig, and I am the head of supply chain globally, at least the tech side, at McDonald's. Today, I wanted to talk to you a little bit about some of the great innovative work that we're doing here at McDonald's. And I know Deborah mentioned that we all know McDonald's quite well, but a lot of people aren't familiar with maybe some of the detail or the complexity of it. So for anyone who isn't familiar with McDonald's, we're a burger company that makes the Big Mac, and we also invented the Chicken McNugget. We've got over 45,000 restaurants in roughly 120 countries around the world. And every day of the year, we serve approximately 1% of the world's population. To keep all of this running, we have over 2.2 million people working in our restaurants, and thousands of developers keeping all of our technology on the cutting edge. So as you can imagine, we don't do anything small. To help explain our scale, as I mentioned before, we're in 120 countries, and we work to source much of our food locally. This means that we have suppliers around the world, both big and small, who help us feed the 1% of the world's population. To give you some perspective on the scale, this is what it looks like from a world map perspective. And I have some more fun facts to help bring this in perspective. So in the US annually, we source over 2 billion cage-free eggs. They flow through our supply chain every single day. This is enough eggs to go end-to-end around the world 3 times. And if you wanted to make an omelet, it's a big enough omelet to fill 40 Olympic-sized swimming pools. That's a heck of an omelet. For those of you not into breakfast, let's talk about burgers. Since we don't release global burger numbers, and AI is kind of part of the conversation here, I thought I'd use AI to help me get some estimates about our burger claims. AI came up with an estimate of 2.36 billion burgers sold globally each year. That's roughly 75 burgers sold per second, our 6.4 million sold daily worldwide. To make this many burgers, it takes an awful lot of raw ingredients: beef, cheese, onions, and buns. So some of the key challenges facing our industry, QSR industry as a whole, is regulatory reporting. There's a lot of regulations like FSMA and EUDR that are out there that we're required to comply with. We need to ensure food safety and that our standards are supported worldwide. We need to meet and report on our global commitments around sustainability. And most importantly, we need to provide supply chain visibility, which is knowing where our inventory is within the system. And actually, our supply chain visibility actually supports the other 3: regulatory reporting, food safety, and sustainability. So as I was saying, out of all of these, visibility is the foundation that enables all of our other priorities. Enhanced visibility allows us to verify sustainability sourcing locations, improve our regulatory reporting and accurate data, and quickly identify the origin of food quality issues. Beyond compliance, visibility drives better investment decisions. It optimizes our supply demand accuracy and accelerates our real-time, data-driven decision-making. Ultimately, achieving this requires traceability of raw materials across a network of more than 10,000 suppliers. With hundreds of potential use cases, we decided to focus on the following. First, as I mentioned before, traceability is kind of the key to visibility. We also wanted to focus on our sales and operations planning, as this makes a really big impact on how we could successfully support the demand at our restaurants. We also wanted to look at the impact of marketing campaigns and promotions on the supply chain, as they greatly affect how our supply chain functions and the demand that's put on our system. Since traceability is our biggest challenge, and traceability is the foundation that enables all of our other priority use cases, it means at McDonald's we needed to track the location of 1.2 billion boxes annually. This means I need to track almost enough 1-foot boxes to fit side by side to go to the moon. That's a lot of boxes. And although McDonald's is not on the moon yet, although I'm sure we'll have aspirations to get there sometime, this is a lot of tracking. So I'm sure you're asking yourself, we've gone through a lot of background on McDonald's, why does this matter for this discussion? Well, it matters because it means the data surrounding our supply chain resides in roughly 120 countries around the world, at entities we own and many more that we do not. So unlike many of our large international firms, Sysco is a good example, we do not own our supply chain. This means our suppliers, our DCs, our delivery services are all outsourced. Since we try to source locally for our restaurants to support our local communities and also have the freshest possible food, many of our suppliers are local. And although we have lots of global suppliers, it means that half of our data is locally held and some of our data is globally held. So we have incredibly close relationships with both our vendors and suppliers. But as I mentioned before, our data is distributed all over the world. We do own our restaurants, we own their inventory, and we own the decisions on how and with who we procure food and services. We're also responsible for quality assurance and legal regulatory compliance with all global and local laws. So how did we start by solving this visibility challenge? Well, we started by defining some guiding principles. We decided that when working with our over 10,000 partner organizations, we would first decided that we would get all of our data directly from our source systems. We wanted to make sure that all the data we were getting was not adjusted. All of our master data was going to come from McDonald's own systems. And we would not establish connections through third parties. So peer-to-peer connections were main part of our solution. To make sure that we were moving into the world in a modern and ever-changing place, we wanted to make sure that we had near real-time data. And as always, security and scalability are a very big concern at McDonald's, so those were a big part of our initial concerns. From an architecture perspective, we wanted to utilize the AWS well-architected framework. We wanted to focus and take a data analytic lens to ensure our consumers could easily use our solution and we could easily leverage AI capabilities. Of course, we wanted to follow McDonald's best practice and standards, and as I mentioned before, security, security, security. Out of all of this, MCD Track was born. Now, what is MCD Track? Well, it's a solution McDonald's built using the Amazon supply chain solution. We took our guiding principles, we partnered with AWS, and we leveraged their technology that they use to get packages to you within 2 hours. At McDonald's, we're using this technology to build a system to provide traceability globally. We're tracking the delivery of our ingredients that we need to make hot burgers, chicken McNuggets, and delicious fries for you and the 1% of the world population daily. So, technically, what is MCD Track? Well, it's a data lake solution comprised of 3 layers. The first layer is comprised of our data producers. This is where our raw data from over 10,000 suppliers, our distribution centers, and 50,000 restaurants, including McDonald's master data, are all normalized. The second layer we call the refine layer. This is where the near real-time data from producers' multiple data solutions are merged together to gain tracking visibility using our Amazon supply chain solution. The third layer is our insight or curated layer. This layer we use to create reports, provide access to our users, and we leverage it for our AI and ML processing. Now that you understand how MCD Track came to be and a bit about how we manage the data, let's look at the architecture. This diagram depicts the MCD Track solution architecture using the Amazon supply chain solution. What comes integrated with the Amazon supply chain solution comes integrated with a wide array of services, including robust data services with canonical data models for supply chains. Amazon supply chain solution also provides data governance to assure accuracy and timely data updates. It provides LLM-based data ingestion and mapping of external data. It also utilizes AWS's advanced data and AI ML capabilities to monitor supply chain and generate recommendations to improve McDonald's overall supply chain. Let's talk a little bit more about how we're leveraging the AI ML capabilities throughout MCD Track. To ensure we're using the right solution for each challenge, we use different types of models to solve different challenges we're facing. When solving a known and well-defined problem, we use rule-based models. Where data is less structured, we use ML and LLM models, and where our desired outcomes are less predictable, we leverage AI capabilities. These models are layered on top of one another to solve a lot of our more complex problems. So how did we do this? Well, we began by looking at our base inventory data, or our raw data. Our challenge was to validate the quality of this data, ensure it was aligned with the other data being pulled into our new MCD Track solution. Since this type of problem was well defined and had a known solve, we applied rule-based models to tackle this challenge. Using data quality, intelligence, root cause analysis, and simple remediation responses, we're now ensuring quality, reliable data. Once data passes through the supply chain, as we can see here, you can see the raw layer, the refined, and the curated layer. So this combined with data quality engine, which is comprised of over hundreds of different rules, the data is considered curated and now used by our AI and ML solution after it goes through our data quality engine. One example of how we use AI and ML models is our sales and operations forecasting. With the help of IoT, which gives us accurate inventory across our supply chain, plus restaurant sales data mixed with strong AI models, we're able to provide high-value forecasts, which will be included in our S&OP processes. As you can see here, we train the model using SageMaker pipelines. The training data is stored in an S3 bucket and fed into SageMaker pipeline. The pipeline automates the end-to-end ML training process. The pipeline includes processing, training, and evaluation steps, followed by a register model step. The register model step publishes the model to SageMaker Model Registry, and then downstream workflows retrieve the approved model from the registry for the deployment and inference. An inference pipeline consumes the data set from the S3 bucket, processes it, and executes batch transformation jobs to generate predictions. We then can feed these predictions into Amazon Q to support our agentic needs. In another example, we're looking at how our market campaigns are impacting our inventory needs. To solve this challenge, we're starting with base data, adding marketing information and outside influential information like economic data, weather, and public sentiment. Because much of this data is not structured, we began using an LLM-based model to extract much of this data into an MCD track. We then layered agentic AI on top to help us understand the unexpected relationships between, let's say, weather and what people choose to order. This helps us gain insights into these types of non-standard relationships. An interesting fact is, many of our restaurant owners say that our ice cream sales don't fluctuate a lot with weather changes or the change of season. Apparently, people who love ice cream eat it all the time. As I mentioned before, and you can see in this architecture diagram, we're extracting marketing data using the Bedrock LLM models to transform and standardize the data before putting it into our MCD Track data lake. The next step is to take specialized sentiment data and use the combination to predict promotional impact so we can ensure a smooth supply chain. We want to make sure that our customers have exactly what they need when they want it. As you know, most promotions drive a bell curve demand, and this solution could help us enable to address this type of scenario in conjunction with our existing S&OP forecasting processes. This brings me to the conclusion of this presentation and a review of our approach. As you heard, we started with the problem. How do we get visibility into our outsourced supply chain that spans 120 countries and has 1.2 billion boxes a year? We needed to provide McDonald's with complete traceability. We outlined the rules of engagement, or guiding principles, and we wanted to make sure that our solution adhered to those. We then aligned with our vision with our stakeholders and our vendors and started gathering data to create a comprehensive view of the inventory across our system. And last but not least, this is a multi-year journey. We still have a lot more AI to implement and markets to work with, but as we all know, nothing worth doing happens in a day. I want to thank you all very much for coming to listen to me today. It's been a pleasure, and I look forward to hearing from you. Thank you very much.
Thank you so much to Samir and Stephanie. We're confident at this point that as you enjoy your next McDonald's meal or meal at your favorite restaurant, you have now a new appreciation for the level of care and sophistication that goes into crafting that experience. I encourage you all to try the new Grinch meal at McDonald's this week and really appreciate the level of planning that goes into that hospitality at scale. I'd offer you 3 ways to continue to engage with this content moving forward. First, check out Samir's demo in our Industries Expo later today. It's going to be awesome, and you can dive deeper with him. Second, we have a multi-agent demo as well in the Industries Expo that we'd love for you to dive into. And then third, we're always here to help you innovate at AWS. And we invite you to right outside the theater where we can engage with you directly after this presentation and chat about what you're doing and what you're working on and how we might help. So thank you again so much for your time. Have a wonderful rest of reInvent, and we appreciate it.